Hello everyone. In this lesson, you will learn how to create and run subscriber and publisher nodes in Python. In particular, you will first learn how to create and run a publisher node whose terminal window you can see over here. This node publishes the string message with the counter value that's continuously increasing. This message is sent through an appropriate topic to the subscriber node whose terminal is given over here. The subscriber node receives the message and prints the message in its terminal window. Although the structure of the publisher and subscriber Python nodes developed in this lesson are relatively simple, the ROS2 programming skills that you will learn are very important for the development of complex ROS2 packages and programs. The basic principles of programming subscriber and publisher nodes are almost always the same for simple and complex ROS2 programs. However, it is much more easier to learn how to write the publisher and subscriber nodes by using a simple example than by using a complex ROS2 program whose working principle is often not easy to understand for complete beginners. Consequently, we use the simplest possible example to teach you how to write subscriber and publisher nodes. As all of our previous lessons, this lesson assumes that your operating system is Ubuntu 22.04 and that you're running ROS2 Humble. All the Python and ROS2 code files developed and explained in this lesson are provided in the lesson description and in the attachment to this lesson. However, our suggestion is not to simply copy and paste the code, but instead try to type the code by yourself while watching the lesson video. This is a good strategy for learning ROS2. The first step is to create the Workspace folder and empty package. Let's open a terminal. Then, I will move this manual window and I will resize my terminal window such that you can see what I'm typing and such that you can follow the manual. As always, the first step is to source the ROS2 environment. This will create an underlay. Then, in this video tutorial, we will use gedit text editor to edit simple files, and we will use Spider to edit Python files. First, let's run these commands to install gedit. Then let's upgrade, and finally let's install gedit. Okay, as you can see over here, gedit is already installed in my case. However, in your case, you might see the installation progress. The next step is to create the Workspace folders. To do that, we need to execute this command. This command will actually create this folder ws_pub_sub, and inside of that folder it will create another folder called source. The next step is to navigate to our source folder. And in the source folder we will create our package. To create the package, we will be using this command, ROS2 package create, then this is standard thing, build type, and Python, and here's the main thing. This is the name of our package, publisher subscriber. Press enter. Okay, now you can type lsl to see the structure of our source folder, and in the source folder you will see a new folder called publisher subscriber. You can navigate to this folder to see its structure. You can see several files over here and additional folders. We'll be using this folder to place our Python files. Here, in the best interest of understanding this lesson, I will stop for a second and I will briefly summarize the procedure for creating the workspace folder and the package. The motivation for this is that students often get lost while typing Linux and ROS2 commands. So let's summarize. To create the workspace folder, we executed this command. This command will actually create two folders. This folder, which is our workspace folder, and inside of this folder, this source folder. To create the package, we actually need to go to the source folder of our workspace folder. That is, we need to go over here. And then in this folder, we need to create the package. We create the package by executing this command. This part is standard, and this is the name of the package. And these are the three steps. Number one, create the workspace folder. Number two, go to the source folder of the workspace folder. And number three, create the package. Always keep in mind these three steps. The next step is to create publisher and subscriber Python node files. We will place these files in this folder. Consequently, we need to navigate to that folder. There are at least two approaches for creating Python files. The first approach is to use gedit. You can simply run this command to create a publisher.py file, and you can edit that file. This file will contain the source file of our publisher node. However, we have noticed that sometimes gedit does not properly align tabs when writing Python functions, loops, and classes. Consequently, it might be a better idea to use some other program that's more suitable for writing Python files. In our case, we'll be using the Spider editor. I created a separate video tutorial that's part of this course explaining how to install Spider and Anaconda. Over here, I will simply launch Spider. First of all, open a new terminal, then click over here, Conda activate, and after that, execute this command. This command will actually start Anaconda Navigator, and here it's very important not to start Anaconda Navigator from this terminal. You need to open a new terminal and to start Anaconda Navigator. This is because this terminal will be dedicated to Anaconda Navigator. Consequently, if you close this terminal, Anaconda Navigator will be closed. Of course, there is an approach to run Anaconda Navigator in the background. However, this will be explained in the future lessons. Okay, here's our Anaconda Navigator. You need to run Spider. Click over here. And here's our main Spider window. Here we will write our files. Over here, I will simply copy and paste the content of the publisher node. I will erase this part and I will paste the file. Then I will save this file in the appropriate folder. Click on Save As, and over here you need to find the proper folder. You need to click on Computer on the root, then you need to find the Home folder. In the Home folder you need to find your name or your username, and you need to find the Workspace folder. In my case it's over here, it's under Source, then once more, and you need to save the file over here. I will name the file Publisher. Okay, of course you can do that in gedit by running gedit from the window terminal. Let's explain the publisher node. As always, the first step is to import the necessary functions, classes, and modules. This package, called std-messages, contains data types used to communicate ROS2 messages. From std-messages.message we import string, since we will be sending a string message. Then we import RCLPY. RCLPY is the ROS2 client library for Python. Then, from RCLPY.node, we import node. The node class is used to define our nodes. Over here, we define the name of the topic that will be used to communicate messages. The name of the topic is communication topic. Here, it's very important that the subscriber node that we will write in the future has the same topic name, since the subscriber node needs to know the name of the topic that's used to send messages from the publisher. Here, we will embed our publisher node in a class. The class is called publisher node, and this class inherits from the node class. That is, the class publisher node is a child class of the parent class. This is the constructor of the child class. Over here, we call the constructor of the parent class. We specify the name publisher node. This is the name that we can choose. Over here, we create a publisher node. This function will create this object, and the input arguments are, number one, this is the type of ROS2 message that will be sent. In our case, it's string. And note over here that we imported string. Then we need to specify the name of the topic. The name of the topic is topic name, defined over here. And finally, we need to specify the buffer size. The buffer size in my case is 20. However, you can choose any other number. Then we need to initialize a counter that will count how many messages are being sent. Then we need to specify the communication period in seconds. Here, I'm assuming 1 second. This means that the messages will be sent every second. However, you can change this number. You can put here, for example, 0.5 if you want to have faster communication. This function will define the time period of communication, and it will specify the name of the callback function that's called every communication period seconds. That is, that's called in my case every 1 second. In our case, the name of the function is callback function publisher, and I will correct this over here in the comments. And this function is defined over here. So, to summarize, this function will set the communication period, and it will communicate the name of the function that's being called as a callback function. So what is a callback function? The callback function actually defines what happens during our communication. And here's the callback function. First of all, we will create an empty message, and notice that basically this string returns a data structure that's containing our message. Then we are sending this string. So we simply define a string. This is a message number, and we call this counter over here that's initially set to 0, and this counter will be updated by this function. Then we say message to be sent or data. The member variable data of this object will actually contain our string. Then over here, we publish the message. That is, we publish the ROS2 message. This is not a simple string. Keep in mind that. Then we update the message counter over here, and we print the info in the terminal window that's running the publisher node. This code line will actually publish a message that's being sent in the terminal window of the publisher. This is very important. Then we need to define the entry point for our node, and here it is. It's a main function. Here I initialize RCLPY. Here I create the publisher node. I call it like this. And I call the constructor of my class, which will in turn call the constructor of the parent class, and it will execute this constructor. Then, this code line will actually spin the node. That is, it will make sure that the proper callback function is called and that the messages are being sent. The callback function is defined over here. This function is used to send the messages. And finally, for example, when the user presses Ctrl+C, we will execute these two code lines. And this part is standard. Over here, it's very important that this file has the proper name, and the name should be publisher.py, and this file should be saved in the proper folder. The path is in our Workspace folder, in source, then publisher subscriber, and it's over here. This is very important. Next, let's create a subscriber node. Here's the code. And let's explain this code line by line. Similarly to the publisher node, we need to import string, then we need to import RCLPY, then we need to import node. And note over here that we are using the topic name communication topic. And this is the same name as the name of the topic in our publisher node. Then, here's the class that embeds the subscriber node. The name of the class is subscriber node, and it inherits from the parent node class. Here is the same idea as in the publisher node. We call the constructor of the parent class, we specify the name, subscriber node, and over here we create a subscriber. We use this function create subscription. We specify the data type of the messages that will be sent through the topic, or better to say that will be received by the subscriber. This is very important. This is the type of the message that's being received by the subscriber. Then this is the topic name. That is, this is the topic name that the subscriber should subscribe to. Then we need to specify the callback function. This is the function that will be called automatically when the new message arrives through the topic. And over here we specify the buffer size for the messages. We use this code line to prevent variable warning. Then, this is the callback function, exactly the function used over here. So what's happening over here? This function receives a message. Then, what it does, it takes that message, it receives the string, and it simply prints the string to our terminal window. And that's it. Simple as that. So let's repeat this class once again. Our constructor, in the constructor, we call the constructor of the parent class, that is of our node. Then over here, we create a subscriber. We specify the type of a message that we expect. It's a string. And again, this string is precisely this data type over here. Then we specify the topic name that we are subscribing to and that we are expecting message from. Then we specify the callback function and we specify the buffer size for our messages. Here is the callback function. This callback function will simply print the received string to our terminal window. This is the entry point for our code. It's called main function. We initialize RCLPY. Then over here we create the subscriber node. I will correct it here. This will call the default constructor. Where is the default constructor? The default constructor, this one, it will initialize the variable, it will create all the necessary things that it needs to create, and it will make sure that this callback function is called. and over here we spin the node. This will actually start the node and it will make sure that the proper callback function is called. And finally, we destroy the node over here. And this part is standard. That's it. Now, let's save this file, save as, and let's verify that the folder is correct. You can see the path. The path should be in our Workspace folder under Source, Publisher Subscriber, then in another folder, Publisher Subscriber, and I will call this file subscriber.py. This is very important. Okay. After saving this file, you can simply close Spider or any other editor that you use to write Python code. And let's continue. Go back to the original terminal. In this terminal, we created a package and we created a workspace. Let's type lsl to see that we have the proper file in this folder. We have publisher.py and we have subscriber.py. This is very important. In the step number 3, we need to add dependencies, we need to create entry points for our code, and finally we need to build the package. Our package depends on the packages rclpy and standard messages. These are the two packages that we used in the Python code. The next step is to add the dependencies. That is, we need to tell to ROS2 build system that our package will depend on rclpy and standard messages. To do that, we need to go to this folder and in this folder we need to edit this file. Here is the file. Over here we need to add 2 additional lines. We need to add these 2 lines. These 2 lines actually tell to ROS2 that our package depends on rclpy and standard messages. Save this file and close it. Okay, next we need to create the entry points for our package. To do that, we need to edit a file called setup.py, and this file is actually located in this folder. Here it is. However, just in case that if you moved away from this folder, you need again to type this, and let's edit our setup file. What are the edits? Over here, we need to create entry points. And I will simply copy and paste the proper definition of entry points. What I will do, you see over here the entry points, it's actually a dictionary. Make sure that you erase everything over here and type what I typed over here. Make sure that you have a proper alignment with tabs. And this is the main part. Console scripts. This is the key and this is the value. We need to define an entry point for our publisher. So what is an entry point? We need to tell to ROS2 how to start our publisher node. We will start the publisher node by simply writing publisher with few additional commands in the same line, but this is the main thing. This is how I will call my publisher node from the ROS2 perspective. You can also choose any other name. However, don't play with the code while you're learning the basics. Later on, you can modify this code as you wish. So I'm saying publisher, and this is the name that we will use to start our node, and this will be the entry point. The entry point is on the right hand side. The entry point is actually the function that will be executed once we call publisher. Here is the path to that function. It is in the package publisher subscriber in the file called publisher.py, and the name of the function is main. This is very important. So let's go back to our publisher Python file. So let's first find it. It's in the home folder. You need to over here, source, then go here, then go once over here, and here it is. So let's open it, scroll all the way down, and here's the main function. What we are actually telling over here is to go to that main function and to execute that main function. This main function will initialize RCLPY, it will create the publisher node, then it will spin the publisher node, and in the case if you press Ctrl+C, it will execute this. So this is very important. Then we need to define the entry point for our subscriber. Again, I will run the subscriber by typing this name with few additional commands. So this will be the name that will be used to start subscriber. And here is the entry point. Again, it's in the package publisher subscriber in the file subscriber.py, and the function is main. Okay, so let's find that function, open the subscriber, here it is, scroll all the way down, and here is main. What the main will do, the main will initialize RCLPY, it will create the subscriber node, then it will spin the node, and at the end it will destroy the node. Simple as that. Go back to the setup.py and don't forget to save this file. This is the most important part. Then close gedit and go back to the terminal. And let's continue. Next, type ls-l. Let us verify this file. Consequently, type gedit and the name of the file, setup.cfg. The file should look like this. And let us briefly explain these two lines. You don't need to change anything over here. These two lines are actually telling to ROS2 to put executable file in the folder lib. ROS2 run will actually search for files in this folder. This is very important. If you see this, it's perfect. If you don't see this, you need to add this. However, almost 99.99% you will see this. Close this file and let's continue. Before building the actual package, it's very important to verify that all the dependencies are properly installed. So let's verify that. To do that, let's go to the Workspace folder. And in this Workspace folder, you need to run this command. This command will actually verify that all the packages are properly installed. And you should see this, all required ROS dapps installed successfully. This means that the packages such as the standard messages and RCLPY are properly installed. They should come with ROS2 installation. And finally, we are ready to build the package. When you want to build the package, again, you need to go to the Workspace folder. This is very important. Then, in this Workspace folder, you need to run this command. And here it is. Summary, one package finished. Perfect. Next, let's learn how to run subscriber and publisher nodes. To run the subscriber or publisher node, you need to open a new terminal. Click over here. Then, in this terminal, you need to source setup.bash. However, you need to source this file from our newly created package and from our Workspace folder. That is, you need to source the file with this path. This is completely way of sourcing compared to creating an underlay that we did at the beginning of this video tutorial. And once you do that, you can run the publisher node. So what do we do over here? We type ROS2 run publisher -subscriber _ subscriber, and we specify the name of the node. The name of the node is publisher. However, this is actually the entry point name. This is very important to understand, because if you go back to the file that's used to define the entry points, that is, if you go to the setup.py file, and we can see this file again by, for example, going over here, then going over here, opening setup.py, you can see the entry point. The entry point is defined over here, and the name is publisher. That's how we use that's the name we are using to start the publisher, and that's precisely what's written over here. I'm running ROS2 run package name publisher underscore subscriber, and the name is publisher. And if I press enter, you can see the following: published message. This is message 0, this is message 1, this is message 2, 3, 4, 5, 6, 7, etc. What's happening behind the scene? These messages are being sent through the appropriate topic further. Okay, next, let's learn how to run the subscriber node. To run the subscriber node, again, we need to open a new terminal. Then in this new terminal, we need to source the setup file of our package, and only after that we can run the subscriber node. Here it is. Before running the subscriber node, let's again go to the setup.py file, and let's see what will happen. I need to type the name subscriber, and this is the entry point. This function will be called. Okay, so you can see it over here, ROS2 run, the name of the package, publisher underscore subscriber, and the name is subscriber. And again, you need to press enter. And here it is. The subscriber is working. The subscriber receives the message. This is message number 74. We are not receiving the message 1 because we started the subscriber node while the message number 74 was in our topic. That's why we can only receive the messages 74, 75, and larger messages. Okay, this is the end of the lesson. In the next lesson, you will learn how to investigate the structure of the subscriber and the publisher node, and how to obtain more useful information.